Hi, good evening, everyone. Thank you all for joining the Area 52 December STEM Forum. So we're going to be recording today's session. So if everyone in the audience could please mute themselves so that way we can maintain a good audio quality, that would be great. And then before we get into today's topic, I'm just going to give a brief introduction of our team. So my name is Isaac. I'm a member of First Tech Challenge or FTC Team 18227, Area 52. And we're a community-based robotics team in Plano, Texas. And this is our fifth season competing in FTC. And last year we advanced to the World Championships for the first time. And where we finished as division semifinalists in robot performance, and we are also received the Think Second Award. And besides building robots, our team is also very active in spreading robotics and STEM to the general community, from teaching kids about robotics, mentoring robotics teams, and doing demos at local events, and also hosting webinars like this. So our team started the STEM Forum 2 years ago, inviting industry professionals to share their experience and insights on trending STEM topics. And today's webinar is our third one this season, and you can view the past recordings of STEM forums by searching Area 52 TC on YouTube. So next, I want to introduce our speaker for today's session, Mr. Chung-Ching Zhou. Mr. Zhou serves as the Chief Technology Officer of Optum Behavioral Health, the largest managed behavioral health organization in the United States. And in this role, Mr. Zhou is responsible for leading cutting-edge technology systems and innovations that address the unique needs of individuals with mental health conditions, disabilities, substance use disorders, and children in foster care. Mr. Zhou has authored over a dozen peer-reviewed papers in the fields of human-computer interaction, data mining, and ubiquitous computing, and his work has been published in top industry journals and presented at conferences. Mr. Zhou is also an advocate for underrepresented individuals and groups for their mental health care needs. So if during the presentation you have any questions, just please put them in the chat and we will collect the questions and it will be answered during the Q&A period following each section. So without further ado, please join me in welcoming Mr. Zhou as he shares insights on a highly relevant topic in today's world, how AI solutions are tackling mental health challenges.
All right. Thank you, Isaac. Uh, okay, Isaac, do you see my screen okay?
Yeah, we can see you.
Okay. Hey, it's really an honor to be here with this high-performing team who has won numerous awards. And also what's really impressed me the most is how you guys not only doing the work within your classroom, but the outreach to the society, right? Get engagement from the various different groups, industry, and the academic systems. It's really set you guys to a good success to the future. So today we will be having a discussion largely with what I call the young bright minds on this challenging topic that's really facing not only in the United States, but also you can interpret that across the globe as well, which is the mental health, right? So what I'm going to do today, I will give a little bit data points around mental health, mental illness, some statistics, and then talk a little bit about the challenge we're facing to solve this problem as a nation. And also I will highlight at the end some of the technology use cases and the solutions and some of the architecture diagrams. So I'm going to anytime feel free to ask questions. It's moderated. I will either answer questions from the moderator or I'm not going to be able to see all the chats, so I'm not going to monitor that, but feel free to just interrupt me. Let's make it as a interactive session. So when you look at mental health challenges we're facing as a nation, they're largely categorized as what's called any mental illness, which is something that's diagnosable, right? It's could be the mental health, could be behavioral health, or emotional
Mm.
disorder, right? Something, the keyword there is diagnosable. As you can see the distribution, as a country, we have 23% of the adults that's facing this challenge. That's one out of five, right? So think of a family of five, right? So one within your family or extended family that has a condition requires treatment, right? So that's the keyword there. One out of five adults requires treatment in this nation. Female is slightly higher than male, but then what's most striking to me is look at the age bracket, right? The 18 to 25, it's a 36%, which is seniors or maybe, yeah, seniors or college, right? Freshmen into the early career population, right? Or if you can see in the academic system, yes, bachelor's and master's, some of those are PhD students, right? Those are the young adults age group that's really facing the most amount of challenge. When it comes to some of the social factors like ethnicity, race, there is some difference. Whites slightly higher, Asians, right? As I'm seeing a lot of names in this group, it's not right far behind, right? It's just 17%. And then when it comes to the significant higher numbers, people with the two or more race, that has a significantly higher, 35%. And there is one bar that's not here, that's missing. The LGBTQ community, they are facing 50%. Right? And then similar trend you can see for what's called a serious mental illness. Sometimes people call that industry called a severe mental illness. That is a mental condition that significantly impairs a person's ability to function in their daily life, right? So their productivity as a member in the society is severely limited, right? As you can see, some of those conditions like bipolar, right, PTSD. Again, it's a very similar trend, right? And overall, we have a 6% within adults. Now, when it gets to what do we call adolescents? That's the 13 through 18. I think that's probably middle school. It's like 5, 6 years, right? So middle school through high school, we're seeing 50% of the population is challenged by mental illness. This number is very striking, right? So it's almost one out of two, right? This sometimes is a little bit counterintuitive to people's thinking, right? So students are seen to be happy in the classroom with their friends, right? Play video games, right? Maybe hang out with their friends, but they do suffer a condition like this. And then when it comes to a little bit comparison between high school students and the college students. High school is in the green bar, and the college students is in the red bar. Right? What is the trend? As we saw there, from middle school to from high school to college, right? This number is increasing. So as this group of young bright, what I call young bright minds here, advance into college, right? So we want to be mindful about our mental health, behavioral health conditions, right? So not only just the traditional, what do we think as anxiety, stress, depression, but also there's a eating disorder, right? And suicidal ideation, substance abuse, right? It's a factor in there as well. So this is a chart talks a little bit about how students themselves express their feelings, experience, and the challenges in comparison what's being perceived by their parents, right? So it's a student in green and the parents in this light purple, right? So literally, if you look at this bar, it says 35% of the high students, they expressed their challenges or experience in anxiety or stress, right, in that category. And then what this one says is 34% is almost the same amount of the parents are perceiving the same condition. So there is extremely high correlation here, right? So there is a parents are slightly lower than students, but they sort of go side by side, right? So what does this tell us, right? So it tells us when a student is expressing concerns about their conditions, their parents, they should know their parents is perceiving, is surfing the know of that, right? It's not like students, you think they're in need of help, their parents are not aware. That's not the case. Their parents are aware. That's number one. The flip side of the coin is when parents are perceiving their students, their kids are probably in need of some care, right? They struggle either with anxiety or they struggle with the eating disorder, and the chances are your student is in need of help, right? So those two go hand in hand. When it goes to college, it changes a little bit, right? So the parents, as you see, the purple bars, the parents are almost less in tune with their students, their kids' experience, right? So their students are experiencing a higher percentage of the need of mental health care or behavioral health care, but the parents are probably are thinking their college kids are doing pretty good, which is not the case here, right? So that's the takeaway. So for students in college, right, when you are not doing well from a mental health perspective, your parents are probably not in the know. You want to reach out, right? And the parents who are thinking their kids are doing pretty well, you probably want to think a little bit, give it a little more thoughts, right? Check in with your kids and really see if they're in good mental health and see if they have any needs. So when it comes to students, this is high school or college kids, when they're in the need of mental health, are they seeking help, right? So are they reaching out, right? So are they struggling by themselves, right? Are they developing thoughts in their own bedroom, right? Are they talking to their friends, right? So that's the question we're asking here. So 42%, 51% of the college kids, right, they reach out to help. So half of them are not. So what's the reason they are not reaching out? Right. So for high school students, it's really the concerns of being found out by their friends, found out by their parents, or they simply don't know how. Right. This carries that what's called a stigma, right, of the societal, the negative impression. Now, for college students, they try to reach out, right? So, but the cost is a factor, right? For some students, right? They have loans, right? They have to cover for their food and the rent, right? Mental health is not on their top of the list, right? And then if they were getting to some sort of a counseling, right, sessions, it just takes too long to make appointments. So the availability from the school system or from the society, right? So a few years back, I had focused sessions with the universities, including U of M, including quite a few big schools in the Boston area, right? So their school university counseling center simply ran out of resources. This was actually prior to the pandemic. This was prior to the pandemic, right? They literally did not know what to do with their friend, with their students. They are needing help, right? So this really tells us when our students are running into challenges. They do not really have a way to get the help needed. So from a society perspective, so what are the barriers? So now let's zoom back a little bit, step back a little bit. What are the barriers that's preventing adults or adolescents getting help? The number one factor is access to care, right? So it's almost like think about you have some sort of medical condition, right? Let's just say uh, 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 pediatric care, right? There's not enough pediatricians, or you just the babies, right? They or the kids, they just don't have a way to get the pediatrician care, right? So in this case, it's mental health, right? So it's access to care. That's the biggest barrier, right? So there as you think about it, there are multiple reasons for that. One is we literally are running out of professionals, right? Psychologists, psychiatrists, right? Social workers. We just do not have enough of them to provide care. Uh, that's number one, right? Number two, those resources are not at the places that's close to the population, right? So for example, certain geographic rural areas, they don't have professionals. For example, the universities, right? They don't have enough mental health professional around the close to campus, right? They can take a bus to. Um, and then the certain social societal populations, low income, right, underserved communities, they probably don't have those kind of access. So that's number one. Uh, Number two, it is stigma is still there. There in the recent years, right, talking to the uh, mental health, behavioral health professionals, stigma in the society is getting better. People are more self-aware, right? They are advocating for help, but stigma is still a factor there. Um, this is a challenge that's really delaying the treatment, right? With someone starting to have the symptoms, right? Because of this, they're concerned, they're worried, they're not getting the help that's needed, right? And then the cost, just like any medical treatment, behavior health is also a very costly expenditure. From students, we saw that from college students, right? Or as a family, financial strains. Uh, Really, from a societal perspective, the way to tackle this problem, number one, um, this is not about how we can sort of reimburse more, reimburse less. It's not about that. When you look at the entire nation, right? So how can you deploy some technologies, right, that can help our professionals to do their job, right? How can we deploy technologies that can have the professional focus on caring for the patients versus administrative type of work, right? Like claims processing, that sort of thing, right? Making an appointment with the members, with our patients, right? Can we have those tools so our professionals they can just focus on care, right, versus admin type of work, right? So this the access to care, it is the primary, the single most dominant barriers in the society right now. If you go into the literature, read through the statistics, this problem is not going away anytime soon. And the increase is still in the demand, the need for mental health care is steadily increasing, and the service provider uh, uh, it's not increasing, it's not matching up that way. So that's the single most important factor there. So all the solutions we're trying to provide. It doesn't really matter if it's a policy or it's a technology or it's a clinical solutions. It's mostly centered around access to care, really putting the help, putting the care in the hands of those needed the treatments. So, so with that in mind, right, what technology help? What AI solutions can help? Right. So obviously, these are just some examples, right? Just brainstorming, right? Get your thinking from the various different perspectives, right? So access to care, right? So when we have, like just thinking about the use case, right? A college student, right? Either it's at the library, right? In the dorm, right? In the hallway somewhere, right? It's getting stressed out, right? Needs some sort of a professional help there, right? What can that person do? Think about that and picture that, right? uh, Everybody is so used to a cell phone, right? If that person can get to their cell phone, right, start interacting with something, right? Could it be journaling down their thoughts, right? Could it be sharing some of the data with some professionals and then can give some sort of a feedback, right? Whatever that is, to get that person open up, that's the most important step, step number one, right? So in that case, right, with a large language model, this reality becomes a lot more real, right? To have those kind of interactive technologies with those who are in need. That's number one, right? We talk about the shortage of the health care professionals, right? So how can we? It's not about the optimization, right? It's not about the care steering. How can we match the resources with the individual need of a student or adult, a person, right? So uh, not necessarily you have a psychology, social worker, psychologist, psychiatrist, right? Not necessarily you deploy or use a psychiatrist to have the sessions with the student has some sort of stress from a new environment, right? Or from whatever, right? That's not the best deployment of resources, right? So you want to be able to find the right kind of care. Uh, Now that's purely from a demand, supply demand perspective. The number two problem from this resource matching is when someone is developing mental health or behavioral health conditions, we have done a focus study, right, with members come in. They are just not sure where to start, right? It's not like, my temperature is going up, I'm running a fever, right? My body is aching, right? My bone is broken, right? I've got a severe headache. We have the mental health members are not able to expressing what the needs are, right? So there are statistics. I'm not going to cite from my brain here. It takes like a 2 or 3, I thought that was number, attempts or a specialist before they can settle with someone that actually match up to their needs. Early detection and the diagnosis, leverage some predictive analytics, digital what's called phenotyping. Right, this is something that's deployed on the. If you go, you can search for those tools in the app stores. When you call in for help with a certain professional agents, your voice once it starts showing certain tone, there are agents, AI tools are monitoring your voice. Right, your phone is monitoring how you are typing, clicking the buttons. Right, the way you are clicking, that can be categorized into certain of the mode, certain of the indication. Right. Screening tools, we talk about that use case as when you are thinking about yourself, right? A person, right, in the dorm is trying to get started, right? Can that person fill out some sort of assessment forms, right? Get some feedback, right? And then get some sort of care path followed up, right? The last category is helping enhancing provider efficiency, right? This is really like what we mentioned earlier, is helping providers with the tools so that they can spend their time on providing the care, right? 8 hours a day, 10 hours a day, right? If they have to spend 2 hours doing the work that's not clinical oriented, that's a total waste of our precious resources, right? And this pandemic, you all probably have heard this. A lot of mental health professionals got burnout, right? Or in general, a lot of doctors are getting burnout, right? They have very, very heavy sort of load of work taking care of the parents. That's number one. They have a lot of uh, 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 mental health burdens on themselves, right? And the number three, we have a lot of admin type of work they have to perform. So from now, I'm going to switch a little bit into the technical, what I call the technical components. It's more of a application view, right? So I'm not going to get into discussing certain algorithms, but what I would like to have you take away the team members here, right, from this discussion is picture you have an application on your phone today, right? You have a just any, it doesn't matter if it's an Amazon application, right? E-commerce application, or it's some sort of a social media application or search type of application. And that's literally in the green boxes, right? So you as a user, right, you go to some sort of UI that can be on your phone or on your web, right? And then typically that UI will be talking to some what's called an API backend, where people see that, right? And then that backend will get some data from database, right? So this is literally a simple mobile or web application architecture, right? Front end, back end, database. Right? Nowadays, extremely simple. Everything is deployed in the cloud, right? You can do that in AWS, in GCP, in Azure, within minutes. Drag and drop. It's very easy to deploy such application. So then, how do we uh, enhance that application so that it has the what do we call the AI technologies or enablement, right? So think about a case, for example, when someone is typing the different thoughts into that tool, right? Started expressing describing their experiences, typing their conditions, how they feel into a application on their phone, right? On the back end, you can think of that a Gen AI as a very latest popular technology can help you summarize that, right? And what that really need is just an API that can be sent over to the GPT model, right? Nowadays, GPT-4, 32K, right? You give the instructions, you come back. Now, all of a sudden, that journaling application now has the sort of Gen AI capability, right? So you don't have to modify your application at all, right? You just make an API call. So that's one use case. Okay. We'll come back to this. Okay. Another use case is what do we talk about the predictive analysis, right? For example, right, to identify people who are at risk, look at that person's medical records, right? So if this person, there's this what's called a comorbidity, right? Where you have certain physical health conditions, right? Major physical health conditions. There is a strong correlation to behavioral health or mental health conditions, right? So think of that as what? Correlation, right? Just as the word, correlation. So we have our people's medical records, right? So by looking through the medical records, we can start predicting certain mental health conditions might showing up, right? So instead of waiting for the mental health condition gets to the certain stage, why can't we just start engaging that member earlier, right? So this seems to be such a common sense, right? So that's the second use case here, right? How do you do that, right? So you have your medical claims information, right? Medical health record information. It has nothing, it's nothing about mental health, right? You can go through this machine learning pipeline, right? This is a fairly standard, right? Going through the machine learning pipeline, you set up some models. Now, when this member is interacting, or it can be a proactive outreach, right, to the member from their primary care physicians, right, or from the insurance companies. They can outreach to that member, right, to say, hey, right, we understand you're going through this set of medical conditions, right? Can we look at your behavioral health, right? Can we get you connected with some professionals, right? So this is the second use case here. Second use case is really collecting all these data resources, right? You do the data processing, right? You select the features, which factors are most important. It's called feature engineering, right? You select the models, right? I will talk a little bit about the diversity of models on my next slide. And then you deploy the models, right? You train, right? If you do the supervised learning, right? You deploy the model, right? And you deploy a model here somewhere, right? And then your application can call your model through API, right? Obviously, this model needs to be continuously monitored so that the performance can still be there, right? So there's no drifting, right? That kind of scenarios happen. So the takeaway from this one is for us to make a difference using technology or AI technology to solve a problem, a lot of cases, you are not setting up an entirely different sort of application, right? You don't have to do that, right? User experience is already there. Computational, the application architecture is already there, right? What you're adding in is the AI component, right? So just as I'm looking at this chart, I want to do a plug-in plug for the engineering careers, right? So some of you are going to college, right, in the next couple of years. Some of you are doing the interns right now, probably as part of high school, right? So then you can see a lot of the job description says, hey, we're hiring sort of the front-end interns, right? Front-end engineers, right? That's what, doing the web component, right? Or back-end engineers, interns, right? So that's typically the API, right? API slash data. They write Java code, Python code, whatever that is, right? Access data and serve to the UI, right? And then you will say, oh, full stack engineers, which is someone can do both, right? Now, this is interesting now with the AI ML in the picture. You say, hey, we need AI ML engineers or interns, right? So what do? Right? So they are writing the APIs. They are connecting their applications to the Gen AI models, right? Or invoking some of these machine learning models, right, to serve on the applications, right? That's one kind. Another kind, I would say AI ML engineer or maybe the data scientists, right, more advanced people with the PhDs, right? They are reinventing the models themselves, right? So not just consuming the models, they're actually, let's just say GPT-4, right? They are working on GPT-4, advancing to the GPT 4.5, right? So that's the AI ML engineers or data scientists they're working on. There are also, you can see data engineers, right? You see data engineers, what do, right? Data engineers nowadays, they are not typically not work on the database. And that's sort of shifted to the application developers, engineers. They are working on the larger data repositories, right? Data lakes, right? Big data. And they are typically working with the consumers. Either it's a consuming party, either it's setting up reporting or feeding into the machine learning pipelines, right? They do a lot of this data processing, data engineers, right? What's called the ETL process. And then all these pieces need to run on hardware, right? Servers or in the cloud, right? They are what's called, from the Google terminology, is what? It's a site reliability engineers, right? SRE. In the old days, someone had a question? Okay. In the past, I won't say in the older, in the past, we used to hear systems admins, right? DBAs or Unix admins, right? Nowadays, a lot of that is sort of moved into the cloud. So you as a front-end engineer, back-end engineer, you actually have the knowledge of the systems, but we specifically have the SREs. They are very specialized, right? In the performance tuning, in the availability and the reliability, right? And then you hear a lot about the DevOps engineers, okay? Now there's a DevOps engineers, there's a SAC dev engineers. I've heard ML dev ops engineers. They work with the application engineers, site reliability engineers, but their job scope is maintaining those lines, right? Those physical lines, right? So they want to make sure the code is propagated into various different places, right? Monitoring the health of the systems. Anybody has a question or comments? Okay. All right. So that's where we have maybe about 5 minutes. So a couple of slides, just a couple of examples on two use cases, right? There's a machine learning, right? There's a Gen AI, okay? So just give you a sense on the machine learning route. Sorry, I'm gonna going back and forth. So I'm talking about this box, right? This box here, right? So I'm using a real example. This was a research I did about maybe 15 years ago. It's about learning personal, meaningful places, right, from your GPS, right? You have, at that time when I started, there was no GPS on the phone, okay? So I had to order, I still remember it was Nokia, not a Nokia, Motorola i88 phones, right? They had a GPS there. That was the only phone had a GPS chip in there, right? So when you carry a phone around, you started leaving traces of GPS locations, right? But then GPS locations is not logically where you have your places, like your home, your school, your friend's house, right? Your fast food restaurants, right? Whatever those places, the parks, right? So how do you learn that from those GPS locations into meaningful places, right? Which that was a machine learning projects we did. So number one, okay, you need to find out what is your algorithm, right? So you have those GPS locations, as you can see, right? Once you draw them, they form certain density, right? So then you say, well, this is a pretty obvious, right? This is so obvious. This is probably a place this person goes to a lot, right? This is probably a significant place for this person, right? You're exactly right, right? But then when you come to machine learning algorithms, right? You have supervised learning, unsupervised learning, nowadays reinforcement learning, right? You have the deep learning, the pipeline, CNNs, RNNs, again, right? You have the drones, right? When the drone is flying, all those motors, right? If I remember correctly, that was the reinforcement learning, I thought, right? And the financial analysis, a lot of that is based on Monte Carlo methods, right? And then a lot of this concept goes back to, right? You can think of a linear regression. That's a supervised learning, right? You can think about a straight line. That's the right. That's a learning. That's a model, right? That's a focus model, right? And then this work is based on this clustering, right? K-means DB scan, right? That's sort of the clustering algorithms. You need to have your algorithm. You need to deploy and you need to what? You need to evaluate, right? So you evaluate algorithm, what is called recall and precision, right? This is a key concept here. Recall is what? If you're gonna predict, right? If you're gonna predict, this is a place I go to, right? If you predict this is a significant place for me, if I go to 20 places, right? Your algorithm found 10, that's a 50% of recall, right? If I were to find 15, that's a 75% recall, right? So you want your recall to be good. And then what's the precision? Precision says, okay, so I have 20 places to go to, but my algorithm is going to return 200. That 200 covers 220, right? It has like 100% recall, but that's not good because it gave me too many false positives, right? So keep those two concepts in your mind, right? That still applies. When you have an algorithm, machine learning algorithm, it's always about what is your recall and what is your precision, right? That's the fundamental concept there, okay? And then the Gen AI case, right? Gen case nowadays is you open up your GPT, right? Say, uh, tell me about the difference between Italian food and American food, right? So that the Gen AI chatbot will give you some sort of interesting response, right? Now, this is a real use case we have in work that's used to generate a patient's clinical summary, right? As you remember, so I'm going back to this chart, okay? I have this members data, clinical records, they're all here, right? I have this patient's data. I'm going to pack this data. I'm going to send that to my Gen API, okay? I'm going to pack all this person's data, send that to Gen API. In my API request, I'm going to give instructions, right? So this is a very standard set of attributes you define, right? We clearly say you are an accomplished and skilled clinical extractor. Your role is to go through the member data. I'm sending in JSON format, right? That's like XML format, and extract the required information. Okay, so that's your role as this agent. I'm sending input format. I'm not going to list out there, right? So the JSON format, and then what is the output format, right? I have that listed out as well. This is instructions, right? So I say, hey, for member identification, I want you to show me the member's name and age. If age is not mentioned, I want you to calculate age from date of birth. Do not show actually date of birth, right? Just show 30 or 25 years old, but don't show DOB, right? And then again, I say your task is to analyze this, right? Format the output to this, and do not include the field name of the fields, right? I have a few more tasks I ask this agent to do. And then one of the things when you are sending, this is different than you are interacting with ChatGPT, right? Now you are opening this up, this interface to your users. You don't want the agent, the ChatGPT agent, to start giving opinions based on their own, right? So we have what's called a strict instructions. We say, for example, do not give any remarks on your own. This is not our own, on your own. Follow data points to give precise summary, right? So we specifically asked the agent to be very strict, right? And see here, another here. If a member gender is unknown, now or not black, or blank, right? If it's blank, use they, them, their pronouns, but prefer to say the patient, right? So we give all these instructions, send that to the chat 4.0 model, give us back the clinical results. So that's a second use case. Okay, we're almost at a time here. I think we're wrapping this one up. At the end, it's really just I'm gonna leave it on this slide. It's really just a call, right, to action. This is ourselves as both young people. I call ourselves here, right? This is a discussion with this team. And also, I noticed there are some family members or parents who are probably here as well, right? So we both need to work together. Regardless, we're going to be using technology or not, right? We need to hold hands and solve this problem.